This video has been created to assist students in Years 11 and 12 as they prepare for the HSC examination. It includes advice on how to prepare yourself and how to maximise the use of the 3 hours. Firstly, the reading time. You're going to have 5 minutes reading time. I think you should make a decision beforehand about how you're going to use it. You might decide to read the whole exam, but personally I think you should specialise. Perhaps you could just read the multiple choice question, there's 10 of them, or you could go to the question immediately after the multiple choice section where there are some, I guess you could call them bread and butter questions, easy marks for simple processes. If you're feeling game, you might want to invest the 5 minutes in the geometry question, which tends to be very long-winded, and you might take the time to decipher the information that you've been given, and perhaps you might have a moment of blinding inspiration that you can write down straight away when you're allowed to start writing. Or you might go to the good old max-min problem, which is usually very late in the paper. Have a really good read of the information that's been given and what you are required to do. You need to think carefully about time allocation, and you need to have a plan. Some students rush in the first hour and make a lot of unforced errors. Some students go too slowly and run out of time. This is an example of a time plan that one of my students used. This particular student likes to use an old-fashioned watch with hands and would set the watch for 11:55 so that at the end of the reading time the watch would say 12 noon, and then the student knew 20 minutes for the multiple choice section, 12:20, got to move on. 40 minutes for the next 2 questions. By 1 o'clock should be finished question 12. By 2 o'clock should be finished question 15. For another half an hour for the last question. And my advice there, half an hour to go, I think you need to stop and take a really deep breath and have a good stretch, and then read ahead to see what you haven't done yet. You could look for some easy marks in questions 15 and 16. If you didn't finish the multiple choice in that 20 minutes, you could go back and finish that guessing. Guessing is good if necessary. Don't leave any of those blank. You could go back and have another attempt at any questions that you didn't make a substantial start on, or you could check the work that you did do just to make sure that you haven't made any unforced errors and that you have communicated your solutions clearly to the markers. You have a little thing at the back of the exam called the standard integral sheet. Just be aware that the 4 results at the bottom are really not intended for 2-unit students. Not sure really why they are there on this exam, but anyhow, the 7 at the top may be useful. I would actually suggest to you that when the supervisor says you can start writing now, that you might actually want to write a few things on here, like that big plus C to remind you that you may need to write that on the end of an answer, or perhaps a table like this of exact values so that you don't have to think about that during the exam. You can just look at this piece of paper and write down something that might be useful. By the way, the first letter in sine, cos and tan matches up with the third letter in cosec, sec and cot. That's a helpful little memory aid. And so, for example, if you need a value for sec of pi on 6, there it is. There's cos pi on 6 is root 3 on 2, so sec pi on 6 would have to be the reciprocal of that, which is 2 over root 3. Some students like this little memory aid. This tells me that if I differentiate positive sine, I get positive cos, but if I differentiate negative sine, I get negative cos. If I were to integrate a positive sign, I get a negative cos. If I were to integrate a negative sign, I get a positive cos. Helpful little things like that could be scribbled on this sheet for future reference. During Year 11 and 12, it would be a really good idea to make sure that you are really fluent with every single formula you have met. And so this is called my do-it-yourself formula sheet. It would be a massive task to do this at the end of Year 12. It's a much better idea if you do it progressively as you go. And here is an example of how I would fill it in. At the end of each topic, you should be looking for some HSC questions, and so there's a place here where you could write a few questions down in which this formula would have been useful. By the way, there are several different places you can buy collections of HSC exams with work solutions. This is my personal favourite. It's published by the Mathematical Association for New South Wales, and you can have one of those delivered to your house for a very reasonable price. Another piece of advice: in some topics that you accumulate a large number of things that you are supposed to be able to do short and sharp. Here's the question, here's the answer. Good idea to put them into a table like this, and it's been done like that deliberately so that when this is complete you are able to fold that down the middle so you can still see the questions but you won't be able to see the answers, and so you can practice these things 2 weeks before an exam, a week before an exam, the night before the exam, or even the morning of the exam, just so that you are really up to speed. The multiple choice section, it's a bit of a cruel sport, the multiple choice. It's either right or wrong, no marks for working out. Sometimes it appears like there's a lot of work for 1 mark, but usually, given that it's only worth 1 mark, there may be a nice little shortcut you can take, and this is a good example of that. You could spend an awful lot of time working out the probability of each of these and then adding them together. A good shortcut would be to do the opposite, to work out the probability of blue, blue, blue and subtract that from 1. That would give you the answer. Sometimes out of the 4 possible answers, 2 or even 3 of them are quite ridiculous. So in this case, the gradient of that line is negative, and so it's a good idea just to cross out A and C and then consider B or D. Good example here where if you're not really too sure, you could have a look at the 4 possible answers. There are some hints there, and you could try a few different numbers and see what happens. You could, obviously -3 is of some importance here, but when you plug -3 into there, it's undefined. So you could then try -4 and see what happens, and -2 to see what happens, and from that I could safely conclude that the correct answer is A. This is an equation. One of these is the correct solution. So if you weren't sure how to solve that equation, or if you just wanted to be really sure that you've got the right answer, you could calculate these and plug them into there and see which one works. You're going to be using writing booklets. I'm going to give you some advice about, I think, to be the best way to use those writing booklets. I would actually suggest that you have a bit of an imaginary line running down this page, and you only use the space on the left hand side of that line. Part A, blah 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 blah, leave a bit of space. Part B, blah 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 blah, leave a bit of space. Part C, blah 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 blah. Make sure you label all the bits carefully. And the beauty of this idea is that later on you might decide that this solution is actually incorrect and you would like to have another go, and so there is some space here directly opposite your first attempt, and the marker will be able to see your first attempt and your second attempt side by side. You'll notice I did not use liquid paper. I did not obliterate this. This is still readable. You should do that. Sometimes the markers will read things that have been crossed out and may possibly give some marks to things that have been crossed out. But you should cross one of these out. Don't leave 2 conflicting solutions there. The markers are not too keen on that. Advice. These pages are going to be scanned. The advice from the markers is to use black pen. They would like you to write neatly and clearly to give yourself every chance. They want you to label every single bit. They don't want you to use a hard, fine pencil because they don't scan very well. They certainly don't want you to use liquid paper. Leave it at home. You shouldn't write too close to the edge of those pages just in case it gets cut off during the scanning. If in doubt, don't cross it out until you have something better. And when you do cross it out, make sure it's still readable. Cross one of them out. And in the geometry work, just be really careful with angles. This particular angle here labelled with the X, that's angle ABD or DBA. The markers don't like it very much if you were to call that by an incorrect name, such as ADB, which is actually a different angle. So take your time when you are describing angles using 3 letters. Transcription error is where you accidentally miscopy something from one place to another. There are 2 types of transcription errors. This is the first one, where you are reading the question booklet and you are then going to copy some information from there into your answer booklet. Nobody expects you to write out all of that, but something like that would be very helpful, because then you could just push your question booklet to one side and just use your answer booklet without going back forward, back forward, back forward for more information. The second type of transcription error is the self-inflicted one, where you are writing line after line of working, and somewhere in there you could easily lose a 0 or put in an extra 0 or something like that, and that would be very unfortunate. So just be really careful from one line of your working to the next. With regards to your calculator, perhaps you should consider taking 2 calculators with you so that you can set one of them into degrees mode and the other into radians mode. And just to be sure about which one is which, you could put the one in radians on the right hand side of your desk, as in R for radians, R for right. If you really want to be sure, when you press sine of 30 in degrees mode, it should say 0.5, and when you press sine of pi on 6 in radians mode, it should also say 0.5. And when you use your calculator, when the time comes, here we go, working, 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 it's time to use my calculator. It's a really good idea to write down basically what it says on the screen with a few dots after it to indicate that it keeps going, and then to round off and to indicate how you've rounded off with significant figures or decimal places. Some students are a bit confused about expressions and equations and get themselves into a bit of a muddle. For example, here is a fairly straightforward question in which you have been asked to factorize this trinomial. On the other hand, similar question, but this time we've been given an equation. So on the right hand side there, you have 3 options. You could factorize the left hand side, or you could do the process known as completing the square, or you could use the quadratic formula, good old negative b plus or minus the square root of b squared minus 4ac all over 2a. On the other hand, on this occasion, we would recommend that you don't use the quadratic formula, that you just factorize. But what some students do is they want to show that they can go a little bit further, so they insert an equals 0 here and keep going. Please don't do that. This is what the examiners would like to see: a factorized expression as opposed to solutions, as in values for x. If you wanted to be absolutely sure, you could substitute a number into here and here to make sure you get the same value. If you want to be sure about this, you could substitute these numbers separately, one by one, into there, just to make sure that the left hand side will be equal to the right hand side. There are many formulae in the 2-unit course, and when it's time to use one, I would suggest that you write down the formula from your memory as best you can and have a good look at it. Ask yourself, is it really right? And then you should substitute the numbers you've been given and show the working that results in a correct answer. Under examination pressure, it is very easy to make an unforced error. So suggestion, you've tried a question, you've got an answer, you think it's right, you're about to move on to the next question. I think you should do 3 things: stop, look, and think. Firstly, have you really answered the question? Here, for 2 marks, we have to show that the acceleration is always negative. So we've done some excellent work here. We've got something that appears to be negative, but that's not enough. It's a show that question, and so you need to go a little bit further and answer the question that you have been asked using words and symbols and making a concluding statement. Next, have I expressed my answer correctly? In this case, we've clearly been asked to use radians. You can work out the answers in degrees, but the last thing you should do is convert those angles from degrees to radians. Have I done everything? For 3 marks here, they want a value of x and a value of y. Make sure you do both of them. Go back and read the question. Have I really done everything they asked me to do? Does my answer make sense? So here we go. 300 years for half the material to decay. We started with 20 kilos. It's decaying. We've got 1,000 years. So if I write down an answer that's more than 20, it's definitely incorrect. At that point, you need to make a choice. Do I try and fix it now? Or do I just mark it, put a mark around here, come back later and have a go? Is my answer reasonable? Can I somehow check if my answer is correct or incorrect? Well, in this case, you could take this, pick up your calculator, and work out a decimal approximation for that, and then you could do the same thing with your answer and see if the 2 decimal approximations have the same value. Can I check it? Here we have factorized. So the opposite of factorizing is expanding. On a piece of paper somewhere you could expand the answer you gave just to make sure you really did get back to the question you were given. Alternatively, you could choose a random number, probably not 0, 1 or 2, some random number larger than 2, and you could substitute that number into the question, and you could substitute that number into your answer just to make sure they give the same value. This is an equation. You could take your solutions and you could substitute your solutions back into the original equation and use your calculator just to make sure that when your solution goes here, you do get 0. In the HSC there are many questions with linked parts. So the part C here tells me that this is a new question, probably got nothing to do with anything else that's happened earlier in the exam. However, the part 1, 2, 3, 4 and 5 indicate clearly to me that these are all linked. And most of the time this is a bit of a pathway, and the answers you get here are usually very helpful further on in the question. They are pointing you down the pathway. They are not standalone, separate questions. My suggestion, before you begin, you should read the whole thing, all of it, with a highlighter or a pen in hand, highlighting any keywords or important information that you think you're going to need. My second piece of advice is don't give up. Sometimes the last part is easier than the first part. So don't give up. Try every single part of the question. Always keep your eye on these little marks down the side here. You can see that they're all 1s, but this one is a 2. They are there to give you some sort of indication of how much work is required. And here for 2 marks, the answer is there on the page. It's a show that question. You really need to be thinking that I need to show them 2 things before I got to that conclusion. In the HSC there are many questions in which the answer is given in the question. Here are 3 in a row. The answer is there on the page. They're trying to be helpful. They want you to get it correct so that when you continue down the page you won't be using incorrect answers in later work. So read it carefully and do your absolute best to come up with the answer they have given. Here's another one. Advice from the markers. This should be the last thing you write on your page, not the first. This is the answer. This is your goal. You need to convince the marker that you would have achieved this even if it was not given to you. And for 2 marks, you really want to write down 2 lines of working before you write that down. But sometimes you will do your best and you will get something that is different to this. You then have a dilemma. What are you going to do? You could go back and try again. You could try and play spot the mistake. This can be a very time-consuming sport. Some students like to do what's called fudging, which is where you change a few things to make it look like you got the correct answer even though you didn't. This is highly discouraged. Don't do it. The markers don't like it. They will find it. They're paid to check every line of your working, and they will find it, and it may end up being that the result for you is worse than had you just left the incorrect answer on your page. Let's imagine for a moment that you have tried part 1 and you did get an answer, but you didn't get this answer. And then you move to part 2 and you realize that you need to use the answer from part 1 in part 2. So you have a choice. Should you use the answer that you achieved, or should you use the answer that they gave you? Do the latter. Your answer is wrong. If you use your answer, it's going to make part 2 harder, probably. So leave your answer for part 1 as it is, or go back and check it and try and fix it. But if you can't fix it, leave it as it is, and then use their answer for part 1 when you start part 2. Don't use yours. Another situation, you tried to do part 2. You couldn't do it. So you move to part 3. And then you realize that you can't do that either because you need the answer from part 2. Many students just give up at this point. I would advise you differently. I would suggest that you go back to part 2 and you make up an answer for part 2 that sounds reasonable based on the information you've been given. And you write down that answer in part 2, which will almost certainly be wrong, and then you continue and do part 3 using your incorrect made-up answer from part 2, and you show every little step of working out, and there is a chance that you could still score the marks beyond part 2 using a made-up incorrect answer. Here is a question worth 5 marks in total, and a little bit of information at the top and a reasonably complicated diagram. The question is, should I be copying this diagram into the writing booklet? My answer is, for the sake of 5 marks, absolutely. I think you should draw it to scale if possible, neatly and accurately. You could copy it by placing your piece of paper on top of the question booklet and tracing. And then, as you proceed through the question, if you find out more information, add that information to the diagram as you go. And also, if you are taking an answer from a particular place on the diagram, you could highlight that place, or better still, circle the place you are looking. And in your solution, you should say something like, "from my diagram." So it's like leaving a trail of breadcrumbs. The markers can see where you were looking when you answered that question. There are always some questions that require a graph to be drawn, such as this one, 6 marks altogether, and part 3 is sketch the graph. Part 1 and part 2 are there to help you find important information that will help you with the graph. Now, in mathematics, a sketch is not a rough drawing. It's meant to be neat, it's meant to be accurate. If it's a curve, you would be drawing it freehand, and it's supposed to be nice and smooth. If it's a curve, you shouldn't be using a ruler to join the dots. The advice is that you should use a clear plastic ruler, that the axes and straight lines should be drawn with a ruler. If you are going to be drawing 2 graphs on the same plane, it's a good idea to write both equations so that the marker knows exactly which one is which. Should I use pencil or pen? The advice from the markers is that you should draw them with pencil, rub them out if you're not happy, redraw, rub out, redraw, and at some point, if you are happy with your graph, then you should go over it with a nice clear black pen before you hand it in, so that it will scan and be clear to the markers. Many students contradict themselves, which makes the marking very, very difficult. In part 1 of this question, it's clear there are no stationary points, and so when you get to part 3, whatever you do, don't draw a graph with stationary points, because that is clearly wrong. You are contradicting yourself. Here is a little collection, my top 20 graphs. They're all in the syllabus, and it would be very, very handy if you walked into the examination room with a clear mental picture of these graphs and where they would be on the number plane. You also need to know how to take a simple graph, like a parabola in this case, and shift it up, down, left, right. You have to have a clear idea about what that does to your basic parabola and other simple graphs. When asked to draw a tree diagram, nice and big, bigger than a slice of bread. Down the right hand side, a list of outcomes is a good idea, and fractions on the branches, no need to do that if all the fractions are 1/2, and it would be a good idea to highlight or somehow circle the paths that you followed to get the answer to the questions. So just so they can see where you were looking. In the 2-unit exam, you will see many questions that say explain or justify. Your textbook doesn't have many of these. The best place to find these is in the past HSC exams. Here's a good example. Simpson's rule, trapezoidal rule, and then explain why trapezoidal rule gives a better estimate. It's only worth 1 mark. It's not an essay, but they are wanting some words on the page and a clear explanation just to show what you know about trapezoidal rule. Here's another one. Explain why the balance of the account at the end of the second month is this. 2 marks. They don't want an essay, but they do want some words on the page. I'm told it is quite acceptable that you could write a statement like that and you could put little arrows pointing at certain things and little bubbles indicating, you could indicate why, a little arrow here with a bubble indicating why this number is so and why this number is a 2 and where this number came from and where this number came from and why you've got 2 things here added together. And then we have questions that say show that, prove that, deduce, and then there's hence as opposed to hence or otherwise. The words show that and prove that, in my opinion, they're fairly interchangeable. I don't think there's a great difference between them. There is a difference between hence as opposed to hence or otherwise. So here we go. Prove this. So again, this is the last thing you should write on the page, not the first. That is your goal. You're heading towards that. So you might want to start manipulating the left-hand side and show that it's the same as the right-hand side, or you might manipulate this to get that, or you might manipulate both of them to come up with something that is equivalent to both of them but is equivalent to each other. Part 2 says hence. That means they really do want you to use this to go 1 step further. You must. And here again, hence, they want you to use this, but they also want you to use the table of standard integrals to go 1 step further. Here's another example. They're telling you Pythagoras' theorem would be a good idea, but they are happy for you to do it some other way. And likewise here, they would like you to pick up where you left off, but they would be happy if you did it some other way. That's the or otherwise. In your working, please be conscious of the following. That is this. You've been working, got a value for x. That could be wrong. You may have already made a mistake. And then you are going for y. And if this is wrong, this will be wrong. You need to show them how you got from x to y. And if you show them clearly how you got from x to y, you can still get the mark for this, even though it will be wrong. It's very, very important that you communicate clearly. Of course, correct answers are important, but sometimes, if the question is worth 2 or 3 or 4, a correct answer with no working won't be enough to get you the marks. The markers really want to see how you arrived at that answer. It's also possible back in part 1 you've made a mistake, and therefore answers for part 2, 3, 4, 5, they'll all be wrong. The markers are paid to go back and look at everything you did, every step of working, every calculation. They need to be able to see what you were thinking and what you were doing. And if they are convinced that you were doing the right thing, you can still get full marks for everything beyond part 1 for incorrect answers. And finally, a reminder that you should be doing HSC questions from past papers, even in Year 11 and the early parts of Year 12. You should be finding questions, and this is a great place to find those questions with really carefully worked answers. I hope you found this video to be useful, and I wish you well for the big day.